Okay, so I'll be showing a quick quantization demo of SqueezeNet. So SqueezeNet was trained on the ImageNet dataset that contains 1.2 million training images, where the idea is to classify the primary class within each image. So that's from 1,000 classes that can be selected. So in this case, SqueezeNet predicted it's a pirate ship. You can see that it's correct, and that it's a correct classification is indicated by this asterisk between the confidence and the class label itself. So this is an incorrect classification. SqueezeNet predicted as the top one class, it's barrow, garden cart, lawn cart, which you may think is correct. However, the dataset itself has the label hay there. This is a correct classification with a very high confidence. Is a bicycle built for two. So ImageNet itself works on a top 5 accuracy basis. So if any of the top 5 predictions are correct, it counts as a correct classification, as in this case where water bottle is the second highest confidence classification. Okay, so let's just get our initial accuracies here. You can just test the stock standard SqueezeNet. We're going to be using 1,000 images from the validation dataset for this testing. So you can see the top 5 accuracy is 79.7%. Okay, so moving on to the quantization itself. So what we provide is the CDL Compress library. That's Python libraries that actually does the compression, and then we also provide tutorial scripts which you can simply modify for your own networks. So this one is already set up for SqueezeNet. You can simply run it and start the quantization. Okay, so in the initial phase it does a bunch of data analysis. It runs training data through the network and looks at the weights and the activations in the network, collects a bunch of data, and then it quantizes per layer. So this whole process, which should take around 2 minutes, don't need to wait the whole 2 minutes, already done it. So let's just stop here. Okay, so after that we can test the quantized network. The quantized network is still in TensorFlow, so you can rerun your evaluation of the network in the original framework. If we run this script, we should see around a 1% drop in the accuracy. There we go, 78.7%. Do you find this acceptable, given that the going down to 8-bit gives us very good performance on the FPGAs? You can also visualize the quantized network again. Just wait for this to start. There we go. So again, pirate ships classified correctly here. Hay was still classified incorrectly, and the bicycle built for 2 was again classified correctly with very high confidence. Right. Okay, and then there's one final step. That's just the compile step. So that takes it from a TensorFlow graph to a CDL native graph, which CDL design, which we'll be using in the next phase, can work with. So it's simply a script that needs to be set up. It points to this TensorFlow graph, and it just essentially spits out the CDL compiled network. It's a very simple script.